Welcome everybody to this new lecture. Today we are going to talk about doubly linked list. So I assume you've already gone through the singly linked list and you have gone through the programming and the implementation that was discussed in the last class. Now what we are going to do, we are first going to study doubly linked list in the same manner and then we'll do the implementation of doubly linked list. So what is a doubly linked list? If you have gone through the types of linked list, you have single linked list or singly linked list where you have only one pointer. Then you have the doubly linked list and then you got the circular linked list. You can also have circular and double at the same time. So earlier we used to have data and we used to have the next pointer, and now we have a new pointer which we name as previous. You can name them anything, but next signifies the next field and the next node, and previous for us signifies the previous node. So when we create a linked list which is a doubly linked list, we'll be using two pointers. One is the next pointer. If you see, this is your next pointer from first node to the second node, and you have the previous pointer. So the previous pointer will go, this is your previous pointer here. Okay, this is your previous pointer. So to simplify it, this is how I represent my node in the pictorial representation. So I have the data, I have the next field, and I have the previous field. So next will hold the address of the node ahead of this node, and previous will hold the date and the address of the node which is behind this. So if you see here, so if you look at the linked list here, let me just scroll down. Yes, so this is your linked list. There are three elements: 5, 10 and 15. They are at the addresses 1000, 2000, 3000. Start points to 1000, so it has the address 1000. So in the previous linked list where we had only one pointer, in the singly linked list, 5 had the address 2000, which meant it pointed to the next node, and then that is the only data it would carry within the node. There would be nothing which would tell 5 what is behind it. But here you see we have a null pointer behind 5, in the sense it tells you that behind 5 there is a null node or there is no node at all. So 5 is your first node, and when you go check the second node 10, you see that 10 has the address 1000, which means it is pointing to the node 5, and it has the address 3000, which means it is pointing to the node 15. Okay, so now if you look at it, if you start at the start pointer, you can go to the node which has the element 5. From 5 you can go to the node which is element 10, which is a normal linked list operation. From 10 you can go to the next node which has value 15 by way of the next field. These are your next fields. If you see the last field here, it is grounded, which means it is actually null. Now if you are at 15 somehow, you can also go backwards because you have the address 2000, and that is pointing to the previous node. So similarly, from 2000 node you have the address 1000 in the previous pointer, so you can go backwards to the previous node. So if you look at this here, this is your previous, this is your data, and this is your next. This is how this figure is defined. So in doubly linked list, the traversal is in both directions, forwards and backwards. this is the main difference between singly list and doubly linked list. Now what happens what happens in a singly linked list is that we change the structure of the node. So what does the structure of the node look like? I have defined the structure. It has a data field. It has two pointers of the same type as I have defined. I have named one next and one previous. So one will point to the next node and one will point to the previous node. And now I'm using type def to shorten the declaration statements. So I'll be using, after I do this, I'll be using this statement to declare my pointers or variables, whatever I want. Okay, so allocation is similar to how we have done for singly linked list. New node, it is a pointer. It holds the address of type, this is typecasting. DLL star means pointer of the type of structure named DLL. Malloc size of DLL, whatever the size. We put the new data, let's say 50. We put the next pointer as null, and we also put the previous pointer as null. So it's like I have created this node and I'm going to put 50 and null in the next field. I'm not able to write properly in this, so it is just a highlighter I'm using. Null. So this is your previous, this is your next, this is your data. Very bad handwriting though. Okay, so once you are done with this, you have actually created the new node. So if new node is the first node that you are creating, you will assign that value to start. Okay, now just like singly linked list, what you might, when you work with doubly linked list, you will be doing the same things like we did in the singly linked list. So you'll be adding, deleting, add, delete, print, count, search, and you can do many other things based on your requirement. So let's go and jump to add in a linked list. So again, since we are talking about doubly linked list, we are going to do the same thing. Add at the beginning, add at any intermediate position, and add at the end. So how does add at the beginning look like? So again, I have used the same example. This is your original linked list in the straight line here. This is your original linked list. Okay, so this is the new node that I am adding. This is your new node. Okay, I created it using the allocation method. Put all the values here. Whatever is written with green is not what is present initially. This happens later. Okay, so initially there is 50 and there is null in the previous pointer and null in the next pointer. So once I try to add it to my existing doubly linked list, I make some changes. So I have marked the changes with the arrows, so you can see the numbering 1, 2 and 3. So you do the first step. If you remember in the linked list video, I told you if you do this 3-step first, then you'll make start point to this new node and you lose this link here. Okay, so that's why we don't do step 3 first. We'll first connect this new node to the existing first node of the list, but that is step 1. Then you are free to do step 2 or step 3. You can even do this first, 3 first and then 2, or you can do 2 first and then 3. So I have taken the order, but it is important that you do step 1 first. Okay, so we're doing add in a doubly linked list. Let me go here. So we were discussing what steps we should perform in order so that we can successfully add a node at the beginning of the linked list. So we have one, then you can do either two or three. Okay. So this is your add at the beginning. Now, if you see your step one makes your new node here point to the first node. The address of first node is 1000. So in new to next we put start. If you see, start has the value 1000. Okay, so after this change we have 1000 in the next field of the new node. New to previous is null. This is going to be your first node or the start node, so you are going to set your back pointer or the previous pointer to null. So if it's not done already, you do it. So you can set both these pointers null when you actually allocate memory, or you can do it later. Now your start still has the value 1000. So start in the previous of 1000, that means we are actually talking about this node. So in the previous of 1000, which is actually here, we are putting the value 4000. New has the value 4000. So now this 5 node is going to be your second node, and it should point back to 4000, and your 4000 is here. Okay, so you're actually doing this step 2 here. Then you have to update the start pointer. Now start pointer is set to new, which is 4000. So your add at the beginning is done. So moving ahead, this was your add at the beginning. Now let's say we are doing add at a position. Okay, so this is add at a position. So let's say we want to add this new node at position 2. Okay, so that means after 5. So these are your initial 2 pointers that are existing. So we have to modify them. So 5 points to 10, 5 points to 10, and 10 points back to 5. But if we are going to insert a new node between 5 and 10, which is your 50, you have to make 5 point to 50. You have to make 50 point back to 5. Then you have to make 50 point to 10, and you have to make 10 point back to 5, 50. Now again I have numbered the steps 1, 2, 3, 4. If you see, if you do step 3 first, you will modify this value from 2000 to 4000, which is in green. Green is the modified value. So you'll modify it. That means you will break this link. Okay, and you will create this link. And if you do that, you lose the value 2000. Now if you see, you don't have 2000 anywhere else. This green one here is the updated value. So initially both previous and next in 50 are null. Okay, so we will now do that first. So our first step will be to change this from null here to 2000. That means we are going to make 50 point to this node here, which is 10 with address 2000. So we put 2000 here, and you can, after that it's okay because you have a pointer to this. You can do the step 2 later also, but let's say for simplicity we make this new this node point back here. Okay, this is your step 2. So basically when you do this, these connections, they are still there. So we have kind of, we have this as we have, and we have these also. So 50 is also pointing to 10, and 5 is also pointing to 10. Now that we have connected 50 to the linked list after the position where we are going to insert 50, we have to make 50 point back to 5, and we have to make 5 point to 50. So we will update the previous of 50 and put 1000 there, which is the address of the first node, and then we'll make 5 point to 50. Okay, so when you do this step 4, if you do it first, it's okay, it doesn't matter. When you do this step 3, that is when exactly this connection is broken. And when you do step 2, that is when this connection is broken. Okay, so you are left with the linked list without this part. So this is not existent now. So you have 5 pointing to 50, 50 pointing to 10. So again, to add at a position, you have to be 1 before the position you want to add. But in case of doubly linked list, you have a little more flexibility in that. We'll see that in a while. So what are the steps to do add at a position, intermediate position? You loop to the correct position. So you have to write the traversal loop with the position, and you have to stop, let's say for now, 1 before the position where you want to insert. So since we are adding at position 2, you have to stop at position 1. In case of doubly linked list, you can also stop at 2 and then add. We'll see that how we'll do that. Then you follow the 1 to 4 here. Okay, and then once we reach the correct position, we do these steps 1 to 4. So what is step 1? We made 50 point to 10. So in the next field of 50, which was none initially, since we have stopped one ahead of the position where we want to add, we are at node 5. So in the next field of 5 contains, the temp node is node 5, the next field contains the address of the node 10. So we are putting the address of node 10 in the next field of 50. Then, now what is new? Look at it this way. In new to next, what is in new to next? In new to next, you have the address of 10. Your new to next now is 10 after step 1. So you can, what we are doing, we're saying in the previous of 10, you put 50. Okay, in the previous of 10, you put 50. So you could do it the other way around also. Since temp to next is also 10, you could do temp to next to previous. If you remember, I told you, going back up again, I told you when we make this connection here, we're saying new to next, put the address of temp to next. So we are making 50 point to 10. So 50 is also pointing to 10 and 5 is also pointing to 10. So you can use 5 is your temp, temp to next is temp to next to previous, or you can use 50 to next to previous. So we have made the back connection from 10 to 50. Then temp is your 5. In the next of 5, we are putting your new node. Okay. And in the previous of new node, we are putting 5. So this completes your add at a position. Okay. So now, like I said, in doubly linked list, you have a little more flexibility of where to stop to add at a particular position. What if you are to add at position 2 and you stop at position 2? So that means you got to add before that so that your new node is position 2. So we do the same steps, but then to do the addition, we need to do a few changes here. So let's say this is your position 1 and this is your position 2. So instead of temp being at position 1, there is temp is at position 2, and we got to add in between the two. Okay, so what, before we actually make these 1 2 3 4 pointer changes, we have this line of code with us. So what does this line say? If you stopped at position 2, you have the flexibility in a doubly linked list to move back. In the sense, from temp you can get the address of node 1. From node 2 you can get the address of node 1. How? By using temp to previous. So temp is node 2. What is in 2 to previous? You have the address of node 1. So we are done here. Now we have the address of node 1 in our temp. So in new to next we have to put temp. So new to next is temp, which is your step 1. And in temp to previous you have to put new, that is step 2. In temp 1, since we have actually generated temp 1 from temp 2, in temp 1 to next you are putting new, which is step 3. And new to previous has to point to temp 1, so this is your step 4. Okay, so this is how it will be taken care of if you happen to stop at position 2. But for a programmer, you should be very sure where you are stopping, because if you think you are at position 1 and you make the pointer changes, you will see the node added at the wrong place. And if you think you are at position 2 and you do the code this way, then again you will see the results are not as you desire. Now add at the end of a linked list. So how do you add at the end of a linked list? You simply go to the last node and then make the last node point to the new node. So let's say 15 is our last node here. Initially it had the value null, and what we are going to do is, after we allocate memory for node 50, we make 15 point to this new node, that is step 1, and we make this new node point to 50. So you write your traversal loop and you reach the end of the node. How do you do that? While temp to next is not equal to null. When temp to next is null, you come out of the loop and you do the step 1. So temp to next is equal to new, that is your first connection. New to previous is temp. Okay, that is your step 2 here. Forgotten. And then you also have to do new to next is equal to null. If you have not done this already, then you do it here. So green is the updated. So 3000, 4000, you put 3000 here and you put 4000 here. Okay. So now coming to delete. Delete at the beginning. So when you delete at the beginning, you have to make start point to the second node instead of the first node. So first we copy the address of the first node in temp variable. Okay. So now temp has the value or the address of node 5. Then we say start is equal to start to next. What is start to next? It is 1000 to next. What is in 1000 to next? It is 2000. So now start is 2000 for you. But then good programming practice is that once you save the node which you are going to delete in this temp, you have to free it. Okay, for before freeing, you also see start to previous. You have to set this back to null, because now 10 is going to be your first node, so its previous pointer should be null. And then after this, forgotten, you can say, you just have to write free temp here. So this node has to be returned back to memory. Okay, I missed it in this one. Now delete at the end. So if you have to delete at position 3, you have to be at position 2 ideally, because you cannot delete 3 while being at 3, because you have to update this pointer, because when node 3 is deleted, this 3000 has to be changed to null. Okay, so in singly linked list we stopped at position 2 to delete position 3, so we'll do the same thing here. So we stop at position, the second last position. So our temp is pointing to 2000. Your temp is 2000. Temp to next is 3000. We are saving that in temp 1. So we are saving the address of the node we have to delete in temp 1. Then temp to next is null. So this 3000 here has to be changed to null and you free temp 1. So it is the same as singly linked list. But if you happen to stop at position 3, which is the one you have to delete, you can again, like I said, from position 3, you can get to position 2 by way of the previous pointer. So you save the position 2 in temp 1. Temp 1 to next is null and you free temp. Okay, so you can do it both ways, but you need to be very sure how your loop works and where you are exactly stopping. So delete at a position, again, to delete something ahead of you, you better be at this position. You'll need this because you'll have to modify this pointer here. So what modifications you need to do? You have to make this pointer was initially pointing to the node 2000, but now this is going to be deleted. So 2000 will point to this node, which is 3000. So this value has to be updated to 3000 here. And this node, it was initially pointing back here, but now it has to point back here. Okay. So just these two pointer changes and then free. So if we stop at node 1000, that is we are stopping at a node which comes before the node I have to delete. So we first save the value of the next, which is we save 2000 in temp 1. Then we make the two pointer changes which I have labeled 1 and 2. So temp to next is temp 1 to next. So this one was pointing to 3000. Now instead temp will point to 3000. And this is your temp 1. Temp 1, let me show it to you like this. This is temp 1. Temp 1 to next is your 3000. And in the previous of 3000, I'm going to basically make 3000 point back to. So I'm going, when I say temp 1 to next, I'm going ahead and then I'm modifying the previous pointer and making it point to temp. Okay, so I've just given some notes as to what are the values and how this temp 1 to next to previous works for you. You can just go through. These are the values of temp 1 and temp at this point, and this is what you get. You can just relate the values with the code and understand. Okay, so here you have temp here, and then you have temp 1, and then you have temp 1 to next. So temp 1 to next to previous is actually this value that you are modifying, and this you're making point back to this. Then obviously you free your temp node. So if you remember, in case of singly linked list, when we deleted a node, if we reach to the position, or let's say we have to delete at position 2. So when we reach position 2, we actually save a pointer which comes before position 2. We had a modified loop where we would save the previous value of temp before modifying temp, and then we would go here. So when we would stop, let's say at the, this would help us stop at the second last node, as in when temp to next was null, temp 1 would hold the second last node value and then we would use it for deletion. Okay, this is deleting at the end, not at a position. So in case of doubly linked list, we can safely omit this line, because when we stop at temp, which is the last node, temp will give us, by way of its previous pointer, it can give us the address of the previous node. In fact, if it's some node in between, it will give us the address of the new next node also. So programming in doubly linked list is simpler comparatively, and you'll see we can traverse in both directions, and it helps a lot in many programming practices. And when you see implementation of linked lists in your uh, operating system, queues of programs and other things in your probably fifth semester, you'll see that at different places they use different types of linked list. Okay, so the only thing that you have to take care is that you know where you are in your linked list before you make any pointer changes, so that you can be sure that you're doing the correct thing. So whenever you are doing anything or writing any program on linked list, always have a rough diagram of your how your linked list looks like, and this helps you to evaluate your program or evaluate your loop. You can do a dry run of your program with some random values and see if your program is actually running correctly. This is true when you don't have a computer to run your program on. You have to actually do the programming on paper in an exam. How do you check? You do a dry run by using a example linked list like this and then working it out based on your code to see whether your code is working perfectly. Okay, so this is your doubly linked list. Okay, so you also have to do print a doubly linked list. You also have to do uh, count, search, and all those things. They are the same as we have done in linked list. So nothing different, just that your program will have a different structure like we had here. Your structure is different. You have two pointers. Yeah, here is your structure. You have two pointers. If you see, when I have defined the structure, just draw a figure. There are actually three parts to the structure. I don't know if I can draw over it. Yes, there is this data part, one block, then there is this next pointer, and then there is this previous pointer. Okay, so one is data, the second one is next, and the third one is previous. And if you see how I represent this here, that doesn't mean that in memory 1000 comes before 10 or 3000 comes after 10. This is just for explanation to help you understand the working of a doubly linked list. In reality, there will be 10. The structure, how it is created in memory, it is created like a block with its defined boundaries. For data, int, the number of bytes it takes for int to be stored, the number of bytes it takes for a pointer to be stored, pointer of the type struct. So it will be a block defined like that. It's not necessarily going to be previous pointer first and then data then next. This is just in the picture to explain or make you understand how it works. Okay, so this is your doubly linked list. I'll end this lecture here. I would encourage all of you to actually start writing your programs. For I have discussed each and every functionality that you probably would implement based on with small lectures that I've done before for singly linked list, and now it's doubly linked list. We have also seen the implementation. That's how your program should run. It should be running continuously till you press exit, and you should be able to. You can also put a default print at the end of every function so that after you do an addition or deletion, you don't have to every time select the print option. The linked list is printed for you. Okay, so in the next lecture, I'll try and see whether we can do linked list implementation. You will not see much difference there because uh, visibly it is just like a linked list. There is an extra pointer, but you will not see that extra pointer. So you go through and try writing the programs first for singly linked list, and then you just have to modify it for doubly linked list. If I have the program written, if I run it visually, you'll not see any difference whether it's a singly linked list or a doubly linked list. Visually, when I print the linked list for you, it is the same thing. It doesn't tell you there are two extra links or two pointers in the field. So uh, the next topic we have to do in linked list is circular linked list, and there are some little applications that I would want to discuss, and there is also uh, one example of a polynomial manipulation using linked list. So I'll be taking that up probably in the next lecture. So for now, good luck with your programming. uh, I would ideally want all of you to implement it because this is the basic data structure that you would be needing all the way in your computer science life. Okay, all right, thank you, bye bye.